Ice, I can't believe it. I feel like I've been living School of Ice for about the last 6 months daily, and I know Bill feels that way too. And I just can't believe we're on the last day already. I think we have a really nice day to finish up with, and that you're going to get a lot of good ideas, and I'm excited about it. So we're going to start with one of my favorite activities called Nature versus Science. And this is also one that in School of Ice has been a favorite of a lot of people. So it was a challenge to figure out how we could do it virtually, but I think I'm hoping, you are my guinea pigs, I've never done it this way, so we'll find out. So Nature versus Science is an activity that introduces how science works, how scientists work. So it's really the nature of science. What do they do as scientists? And it also has to do kind of an environmental scientist toward theme. So in Nature versus Science, it's a card game, and you have two people, usually two. We can tell you how to adapt it if you do it in classes, and I'll show you how to adapt it to your whole class virtually. There is, in a two-person game, there's one scientist and one person is nature. Each person has a deck of cards, ace through jack. So you're not going to use kings, queens, or jokers. And notice that jack is 0, ace is 1. Now, I'm going to go through rules kind of fast. If it's the first time you've heard it, don't worry, because we're going to do examples together and you'll get it. So one scientist, one nature, each has a deck of cards. Nature responds according to a law. And that law he or she receives from the teacher. They can't think about it. They can't do anything but respond according to the law. The scientist has to determine what the law is by playing cards, by testing ideas. And nature responds again by playing cards back according to the law. When the scientist makes 3 consecutive correct hypotheses, he or she will have a valid theory. And then the scientist would go out and get a peer-reviewed paper published about it, and they'd be really excited. They'd also want to be really careful because they don't want to put something out there in print that everybody jumps on and they find out it wasn't a valid theory. So nature will never tell the scientist, nature can't talk, nature's never going to tell the scientist if he or she is correct or not, and will never reveal the law. That's the fun part, especially if the students are together, because you know, I had students that at lunch walking down the hall going, tell me what it was I right? And they're going, no, can't tell you, I'm nature. The scientist has to be satisfied with his or her theory because nature can't tell them if they're right or wrong unless someday their theory is proven incorrect. And that's the nature of science. That's how this works. So players then change places, get a new law, and they play again. Now, that's a lot of rules, so let's try it together. We're going to do an example. What I'd like for you to do is open your mics, and we're going to try this just with you calling out answers. I did this one time at AGU with about 100 people in the room, and they were calling out answers in the room, and it worked. So I don't know why it won't work with 14 or 15 of us on Zoom. So let's give it a shot. Here we go. First of all, does anybody have any, well, no, let's do the example, then you can have questions. So the scientist is going to play first. The scientist throws down any card that the scientist wants to throw down. So the scientist says, okay, I'm going to play a 2 of hearts. Nature responds with a 4 of spades. Now, my question to you scientists is, what could nature's rule be? With all we have is we've observed something and nature has responded. What could it be? Just call out some answers.
If there's a red, play a black.
Okay, red, play a black. What else?
Even play even.
2 times.
Okay.
2 times more.
It could be twice as much. It could be +2. I think I heard both of those. What else?
If you put it even.
So whatever the
down,
sign.
Could be, if you play a heart, nature responds with a spade.
Okay, could be that. And Paramita and Carol, is that what you said?
Yeah, it amplifies. Yeah, that's
even
what I said.
play and even.
A positive to negative response.
Can we go back? Tell me that again. Tell me what you're thinking on that one. What do you mean a positive to a negative?
Red, let's say red is a something development. We think that we develop the houses. It has an impact twice on the nature, and it is negative impacts. I was thinking,
Oh, okay.
we think
Okay.
like in terms of, yeah.
Okay. So this time, scientist is going to say, well, I've got all these ideas. Let me try a different suit and a different number. So I'm going to play the 7 of diamonds. And nature responds with the 9 of clubs. So
have
think of
odd to
what we've
odd.
already said and think, was there anything we need to throw out? Was there anything we could add to what we're thinking? Is there anything you want to keep? What are the things we need to repeat so we remember them?
Okay,
Plus
don't red,
two.
times 2 doesn't work.
Okay, we got
Yeah,
to,
plus 2,
what else?
plus 2. There's
Still
two,
have
two
plus
plus.
2. That's good.
Red to black works still.
Black
Plus
works.
2 and red to black.
Say it louder, Ben. I couldn't quite hear you.
Plus 2 and red to black.
Oh, maybe it has 2 things. It has to add 2 and be red to black.
Right.
Odd to odd, even to even.
Even to even, odd to odd. Okay.
And you could add a new rule of diamonds to clubs.
Okay, we had hearts to spades, diamonds to clubs. So let's remember those. Let's try another one. Scientist says, hey, I think I know what's going on. I'm going to play a card and test this. I'm going to put down the 5 of spades. So using our rules, what do you think the next card will be?
Red.
7 of hearts.
Okay, if we're right about
7.
black and red, it's going to be a red card. What else?
3.
gonna be an
It's gonna
odd
be
number.
3.
I
Plus
heard a
2.
lot of voices. I'm sorry.
Plus 2.
Two.
7.
It will be 3
3 or 7?
7.
because the 4 spade is 2 plus 2 after the, it will be 3 heart.
Red
Uh,
5.
Rose, we had 2 and added 2 and got 4. We had 7 and added 2 and got 9. So if it's that same rule, we take 5 and do we go to 3 or do we go to 7? I'm hearing both.
7.
7.
7.
Red
We can't
5.
be 7 because red is smaller than the blacks.
She has a different role. She's saying that there's always the same relationship red to black. So it could be either. So she just has a different
Because the red-
hypothesis.
Red, 2 and 7, 2 reds are always two less than the blacks.
I see your rule, Rose. Yeah, that's very cool.
I think
It's an
hard
inverse
game.
red. We call it the inverse red rule, I think is the official.
Sorry, that's what I thought. Okay,
Yep.
maybe 7 for
IRR.
others.
I love we're all assuming that Lois' nature is making sense.
Okay, so
Subtract 2
we have
from
a
7
lot
gives
of
you 5, and 4
ideas.
from 9 gives you 5.
Rose, I think you said 3 of hearts would be the right card. And,
Yes,
But I heard a consensus of another card. So let's remember Rose's. What was
7
it?
of hearts.
7 of hearts.
7 of hearts. So let's see what comes up here. Whoa, okay. So Rose is going to have to rethink what she was thinking. But now, did this reinforce some of the other rules that we already have?
right, top is smaller than the bottom.
Okay.
Spades
So
leads to hearts, hearts leads to spades.
that still stayed the same, didn't it? Spades and hearts are still related, which I would, and it looks like +2 again. So let's try another one. Now the scientist is feeling more confident. And, you know, scientists, you oftentimes work in big groups and have that consensus idea that Bill was talking about. They also come together. When I was in Andrill, I got to go to a couple of big meetings, one in Florida, one in Italy, where they presented their ideas for papers. And wow, was that fun to be the fly on the wall. I mean, they argued and brought up evidence, and it was really cool to see that nature of science. So that scientist says, okay, I'm feeling pretty darn confident here. I'm going to test it the second time. Now, let me say something. Scientists could have played maybe 15 cards before he said, okay, I've got a first hypothesis. You're not stuck with this many tests. You can test as many times as you need. But the scientist says, okay, I'm gonna play the 4 clubs. So using the rules that we've thought of, what do you predict the next?
6 diamond,
Red.
red
Red?
diamond, yeah.
6 of diamonds.
6 of diamonds.
So if we're right about the club, or the club to diamond and the spade to heart, then it would have to be 2 more and be the 6 of diamonds, and woohoo! The scientists are going, yeah, buddy, we got this one now. We're gonna go for this. We're gonna test one more time, and then we got a paper. Okay, so the scientist plays the Jack of Hearts. Now remember what the Jack of Hearts value is?
0.
So what would nature respond if we're on the right track here?
K, spade, spade of K, the king,
2 of spades.
Do a
The
spade.
spade of king,
Okay, there's no kings.
You, Russ.
Okay, there's no king to play. The Jack is 0.
Oh, okay.
2.
Jack is 0. Okay, then we have 2 of the spade, 2 of the spade.
Whoa, we're gonna go publish. We're gonna have a paper. We are really excited. We got consensus in the group and we're pretty darn sure. Okay, now there's one other rule that's really important, and that is that nature must play the first card in their hand that fits the law. And by the way, all these rules are in the packet that you can download, and the laws are already there. So you don't have to do this, but you can write it down in your notebook, and you'll have it. So now what we're gonna do is switch to another camera, and we're gonna actually play a game together with real cards. Any questions about the rules?
So what is
So-
K and the queen is equal to in terms of numbers?
You don't play with the queen and king, you pull them out.
Pull up, okay.
Queen and king and joker, you're not gonna play with at all.
Okay, my question is, do you wrap around? You know what I mean? If you played a 10 and it was +2, would it be an ace then?
Good question.
A
If you'd
10,
have to run some experiments to figure that out.
Yeah.
actually there
I'm
is,
just saying, if the rule was to add 2, if you had a 10, would it be an ace would be the response?
for a 10, since there isn't a response, right? Because there's no 12. So what happens in this game, what would happen in nature if you did something out in nature and it didn't have any effect on nature? What would the nature?
Did you get a 0? I mean,
You get
or would
nothing.
you would get no,
You get a
you
null.
no results, right?
You just get no response. There's no response.
Special circumstances,
Say again?
if we consider them special circumstances. I'm just kidding. Never mind.
It would be,
I just, when I play it in class, because this happens a lot, they come to the, you're adding 5 on or whatever. I have them wrap it around, but I just did that because I didn't know what else to do. So
you could do that, but I would.
the same way the Jack, if it's a 0, it's kind of the same concept. And then we got a 2 after the
Just
Jack.
nature, if you go outside and you do something and it doesn't cause any change in nature, then it's a no response on nature's part. There is no rule for it, so there's no response. There's no law of nature for that. But you can play it anyway. So we're gonna do this together. I would suggest that you put your screen on, what is it, speaker view?
Yeah, speaker
And
view.
then I will bring my camera up a little bit bigger. I will call out what cards I'm putting down, and we're gonna try this. I'm not sure how well it will work, but we'll give it a try. You know what I'm gonna do is I'm gonna shuffle the cards. I have not made a plan for how these cards are gonna come up, and I'm gonna prove it to you.
Nothing up your sleeve?
Real game, I have no magic here. So, but I have a card for scientists and a card for nature.
Russ has brought on reinforcements to
I
help.
did. I have a budding scientist.
Hey,
So his name is Rowan.
hi, Rowan. Nice to meet you. Well, you can learn how to play this game and help him out. So, he's going to need help on this. Okay, so the scientist is going to. I didn't take out the kings. Hang on, I made a mistake right away. I did it in the other deck, but not this one. So remember, no ace, no kings, queens, or jokers. Yeah, what I'm really doing, of course, is stacking the deck. I could not do that if I wanted to. Okay, and that's the first step for them all the time would be to take out those cards. Okay, so the scientist doesn't really have anything to observe yet, so I'm just going to pick the card off the top of my deck. As a scientist, you can pick any card you want. Nature now has a rule, and nature has to respond with that rule. So nature's going to pick up the deck, and the first card that can be played according to that rule, they have to play. And the reason for that is really important because your students can't try to trick the scientists because they're hearing them talking about it. Nature can't go, oh, they think it's going to be this. I'm going to play this because it also fits the rule. So they have to play the first one that fits the rule. So here we go. Science played 7 of diamonds. Nature responded with a 4 of spades. What could the rule be?
+3.
+3.
What they are again?
I'm sorry?
What did you said? Can you repeat it?
Yeah, it's a 7 of diamonds and the 4 of spades. 7 of diamonds is the scientist. 4 of spades is the nature's response. I have to get my hands going the right way to get it toward the camera. There we go.
Minus, my bad, not plus.
So we've got one answer.
We need the 9 of club, and then we need 6 of heart.
Okay, it's not the same rule,
We
Rose.
need the 9 of club and the 6 of heart.
Rose, it's not the same rule. It's a new rule. We have to figure out the law. It's a different one. So right now, we're trying to figure out.
Oh, different rule. I see.
-3, right? Was what we said. I think we said plus because we didn't know which way it was going. Scientist is up here, nature's down here. So take away 3 is one thing. What else?
Opposite color.
Diamond to spade.
Opposite colors, diamonds to spades,
Odds to evens.
odds to even. Sounds like a pretty good start. So should I play any particular card or just do a couple of tests and see if any of those work?
Play a black card.
Okay, let me play I'll even play a different suit. Let's go 10 of clubs. So the scientist now has 7 of diamonds to 4 of spades and now a 10 of clubs. Nature's going to respond with a 2 of diamonds. So we have to throw out a couple of ideas. What are the ones we need to throw out?
So black to red's
So-
okay, but not diamonds to.
Odd to even is not working here. Both are even.
Right.
Okay,
Black to red's okay, but not diamonds to spades.
-3 is one that was said too, and that isn't working either, right? Okay, do you
Right.
want to test a card or just do a random one?
Put a red card.
Red card, any particular suit? We've had both come up, just any old card?
A heart.
Yeah, do a heart.
Yeah.
Okay, so now we have a 6 of hearts, and nature's first response to a 6 of hearts is 2 of clubs.
Okay, so opposite color still works.
Opposite color work, even to even.
And maybe that's all it is. There's nothing else.
Yeah.
Okay.
Okay, so if that's all it is, give me some cards to test then. We can do 3 hypotheses, unless somebody thinks we need to do another trial before we go to our hypothesis. Does anybody want to try something first?
So literally, there is no relationship between club and what is spade. No relationship between club and spade.
Okay, so which one play?
One interesting angle on this is she didn't have to look very hard to find a nature response. Now that could be odds, but I think it was her second or third card. So in other words, she very quickly found it. So it wasn't a very, it wasn't like adding pi to this and getting a very specific number. It was getting a black. It took a couple turns. So that implies the opposite color is kind of the limit of the rule.
Good observation there too. That was a good observation.
So let's play another black card.
Okay, in particular or just any old black card?
Play something, an ace. Sorry.
Okay, how about
Club
an
maybe?
So if we're right that it's just black to red, the ace of spades should just be what?
Red.
Okay. Anybody think it'll be red and something else or just red?
Rowan says just red.
Okay.
In the higher number?
What did you play?
A 10 of diamonds. Sorry, ace of spades to the 10 of diamonds.
Oh, I see.
Okay.
Could you play another black, please?
Sure. Any particular one?
First one you see.
First one I see is this one. Four of spades. Oh, yeah, four of spades.
So nature should respond with a red,
Right.
and the suit could be either spades or hearts, diamonds or hearts.
Okay, so I'm picking up the deck. The first card up is a 10 of hearts.
And it was the very first card she picked. Yeah.
I probably shouldn't have said that was the first card, but nature's talking too much. Okay, we have two hypotheses that we checked out. Our third one sends us to publication. So what would you like me to test? Throw out here as test our hypothesis.
Rowan wants a red ace, please.
A red ace. Okay, I've got the ace of
Okay,
diamonds.
Rowan, so what's it going to be?
It's a higher black than just red.
Wait, so you're saying nature's going to play a red?
So no,
She,
black.
Nature's going to play a black.
It's a higher number of black, so it doesn't play a red.
Has to be a higher number than ace.
Yeah. So then, wait, is it possible for nature not to respond?
Yeah, if there's nature can not respond if it's not an appropriate.
If nature doesn't respond, then that is opposite colors when the red number must be higher than the black number. That's the way to do the second one.
You hear his logic?
Do we, well, I couldn't quite hear him because he's talking through.
Here, let's hear it.
My thought is that because I just wanted to see if anything would change with a red ace, because in all the ones except for the second one, which I know wouldn't change much, but I just want to see. Well, in everyone except the second one, the red card has been a higher number than the black card, although they have all been opposite colors. So I just want to see what would happen if you do a red ace.
A red ace?
Yeah.
Right. Okay, so nature has to do the very first card that fits the law. It's that one. And that would be the card that comes up.
Okay, so it's just red.
So
So opposite colors. Opposite colors.
But it's also less than.
no relationship to suit,
Yeah.
right? Okay, do we feel confident enough to go out and publish?
No.
No? What do we need to test?
Well, you got, like Rowan was saying, right? You got like a couple of reds that have a black responding to being lower, right? We have two, and then you actually looked pretty hard for the jack of spades. So, I mean, could the last one just be this weird mistake? I don't know, like or not the last one, but so all the reds that have been played have a black that's less than the red.
Okay, So scientists, if you have a question and we're not confident of publishing, we need to test again. So what would you do then, Matt? What would you want to see?
I'd like to see the ace of hearts.
Well, our first publication will say that red leads to black and black leads to red, but we believe the problem is more complex than that. and our second doctoral student will do that.
All right. Now, I don't know what cards are coming up. Ace of Hearts.
Okay, so it is just black. Or red to black.
So Rowan says it's red to black and black to red with no other pattern.
It doesn't seem unless
We tested it enough that Rowan's feeling confident. Matt, are you confident?
Yep.
All right, we're publishing. Okay, awesome. And it worked. I'm really happy about that. So that was good.
So
But it
You're
took us
not
7
telling us.
seasons, so we had to go down to Antarctica a couple extra years and blew our budget and are now in eat gravy.
there's a somebody in the group might know who to attribute this quote to. I think it might be Albert Einstein. I'm not sure, but I think this game is a great example of the quote that says, "I can do 1,000 experiments and I never proves that I'm right, but it only takes one experiment to prove that I'm wrong."
Yeah.
So I think it's a great example. All you do is gain more and more confidence, but you keep looking because that one experiment might prove that, hey, all of your ideas are wrong. It was fortuitous the way things were coming up. So.
Okay, so we're gonna stop there. This is one that you would then switch partners, and your other person would be your other person then would become the nature, and they'll switch to be scientist. Another way you can do it is if you have an odd number or you don't have enough cards, you can have one nature and then have 2 or 3 scientists. I wouldn't, in class, I don't think I'd go to more than 3 scientists. And we do have a link to being able to buy cards pretty cheaply, $1 to $2 a pack. Dollar store often has them for $1 a pack. So you can get cards pretty cheap. Any questions about this?
I will just comment on this, Louis. This would be a great way to confirm with the graduate students that doing repeated experiment will confirm our findings, like replications, repeated measurements, not only for the in-class, but also starting graduate students, like master's level.
Yeah. Karen?
So when you said you lay down like a 10 and nature doesn't give a response, do you put a card down face down, or do you not put a card, or how do you handle the response? Just shake your head or just sit there?
You get it both ways. Sometimes they just sit there, sometimes they shake their head. Putting down a blank card might be a good idea, because then it indicates all the way through that there was no response there. So I kind of like that. I might use one of the cards I've thrown out, like the backside of a king or something like that, to mark a no response.
Thank you.
Any other questions?
Joker.
Yeah, the Joker could be, haha, I have no response for you.
You can only have 2 no responses.
Say what?
Maybe that's a rule for nature. You can only have 2 no responses.
Well, what do you do if they keep playing cards that require a no response?
That's a good question. I don't know.
I would go with it. Nature's pretty consistent. Well, nature's not always consistent, but there are laws that govern how nature is going to respond in the instances. So those are the laws we're trying to discover when we're out there observing nature and observing any kind of science.
So the other thing I would throw in is that most of the laws are more complex than the just red to black. So
yeah, and in the list of laws, they go from easy, and I always tell the students, easy is only if you know the answer. If you don't know the answer and you get an easy one that's not, it can be very difficult. So if you know the answer, of course it's easy. Some of them get much more complicated, and those get to be, I've had in School of Ice a couple of times, we've had people testing 20 times and not being able to come up with a pattern, and then bringing in the other teams to look at what they've done and see if they can eke out any kind of pattern. And then at that point, it probably shouldn't take that many. At that point, you might even check whether the answers, the responses from nature were correct, or did they make a mistake in their recording what nature did? You know, could have been nature making the mistake because it's really a human, but we'll call it
You
a,
could always do this under a time requirement too, because, you know, stress to experiment and publish or perish kind of idea is an added element of how fast you sometimes can think through logic. Whereas if you had an infinite amount of time, you know, might come easier than having your department chair breathing down your neck for a paper.
okay. Hope you like that. Yeah.
Layla asked a good question. That she asked if this could be done with shapes and colors for younger kids.
With, I'm sorry, with what and what?
Layla asked if this could be done with shapes and colors for younger children. Like if we were doing like outreach or something, this might be, that might be a really cool.
Very cool.
Yeah, like just picking 4 colors, so they're not worried about like the numbers, just saying like, if I have a blue square, what does it lead to?
Yeah.
That type of stuff.
Yeah. I've done this as low as 4th grade with cards, and it works well with 4th grade. I haven't tried it younger than that, but I like that idea a lot.